Okay, welcome to Module 6, and for today's activity, I have three grids or pieces of graph paper for you, and each one has a lizard, a cactus, a rock, a pond, and a line. And look, we even have the sun up there in the corner, okay? So you'll have one, here's a second one, and your third one. To do the translation, the curriculum did not give us a large enough grid to make that happen, to do what we're calling not a translation, but a reflection over this line. So I had to add to the grid for your third one. But there it is. So let's get going and have some fun. Welcome to Geometry 2. All right, this is called 6.1 Leaping Lizards, and this is a develop understanding task. Note the lizard here in the corner. Yeah, we're going to play with this lizard today. So, animated films and cartoons are now usually produced using computer technology rather than the hand-drawn images of the past. The old Disney cartoons and stuff, every scene was just drawn by hand, and it had to be redrawn several times in order to animate it. That was pretty tedious, but amazing. Now we use computers to do the same thing. So computer animation requires both artistic talent and mathematical knowledge. Sometimes animators want to move an image around the computer screen without distorting the size and shape of the image in any way. When we do that, that is called a rigid transformation. You're translating, reflecting, or rotating a figure, but you are not distorting the shape or size. So this is done using geometric transformations such as translations. And translation, what is it? Well, let's take our lizard, and if I just slide that lizard across the plane, like look at the tip of the nose right here. If I slide this lizard so the tip of the nose ends up right there, that is called a translation. And notice something, the lizard didn't rotate at all or flip in any way. It's just a straight slide. And that's why we can call translation slides, by the way. Now next, a reflection. So with a reflection, we take our lizard and we reflect it over a given line. So picture this lizard reflecting over that line. See the tip of the nose? Wouldn't the tip of the nose end up right over here? Yeah, all right, and that's why, and that looks like a flip, all right? That's why some people call reflections flips. We want to use the official verbiage though, okay? And then finally, rotations. Well, rotation, let's take our lizard and picture an anchor point like the tip of the nose, and to do a rotation, we need a point that we are rotating about, and then we need an angle, measure, and a direction. So this looks like we're going to take our lizard and we're going to rotate it about this point 90 degrees counterclockwise. And picture what's going to happen if that rotation occurs. That's right, there's our rotation. It looks like we just turned it, almost like a clock going backwards right there. And that's why some people call rotations turns. Okay, or perhaps we're going to do some combination of these transformations. These transformations need to be precisely defined so there is no doubt about where the final image will end up on the screen. So welcome to computer animation in the 21st century. Okay, so where do you think the lizard shown on the grid, which we cannot see yet on the following page, will end up using the following transformations? The original lizard was created by plotting the following anchor points on the coordinate grid and then letting the computer program draw the lizard. The anchor points are always listed in this order, and I struggled with this order right here. We always start with the tip of the nose, and then the center of the left front foot, and then the belly, and then the center of the left rear foot, the point of the tail, the center of the rear right foot, the back, and then the center of the front right foot. All right, and here are these anchor points right here. For instance, that 12-12 is where the tip of the nose of our lizard is going to end up on the grid. So here it is, and here's that lizard right there, and they have highlighted those anchor points. For instance, the tip of the nose right here. The coordinates of that point would be 12, 12. And then we go center of the left front foot. That would be right here. And the coordinates of this would need to be 15, 12. And then we go to the belly. and I don't know belly in the back, but they call this the belly and that the back. Okay? So anyway, the coordinates of the belly would be 17, 12. And then the center of the left rear foot, right there, and that would be 19, 10. And then the point of the tail, well, that's right there, and the coordinates of that would be 19, 14. And then we go to the center of the rear right foot, which is right here, and that's going to be 20, 13. And then the back, which right there apparently, and they're going to call that 17, 15. And then finally the right front foot, right there, and the coordinates of the right front foot would be x equals 14 and y equals 16. Now, that's our pre-image, and we're about to do 3 transformations of this pre-image. We're going to translate it, we're going to reflect it, and we're going to rotate it. Okay? And it looks to me like we're going to translate this lizard so that it is resting on the rock. And then we're going to reflect this lizard over this line right here, okay, like a high jumper. And then we're going to rotate this lizard so it's jumping right into this pond right here, okay? So this is going to be interesting. So each statement below describes a transformation of the original lizard. Do the following for each of the statements. Plot the anchor points for the lizard in its new location. Connect the pre-image and image anchor points with line segments or circular arcs, whichever best illustrates the relationship between them. Okay, and we're going to start with the lazy lizard. We're going to translate the original lizard so the point at the tip of its nose is located at 2420, making the lizard appear, that should be appear, not appears, appear to be sunbathing on the rock. Okay, so it sounds like they'd like us to translate our lizard so it is resting on this rock over here. So on the previous slide they said, translate so the nose is located at 2420. And it looks to me like they already highlighted that point 2420 right here. So we're translating. That means we're going to slide this entire lizard so this tip of the nose ends up right there. Okay? Now, let's think about that. Okay? We're going to do that with every original anchor point on this lizard, and then the computer can draw the perfect lizard for us. All right? And I've been struggling with my order here that they're doing these things in, so but I'm going to try to do every transformation of anchor points in this order. I'll do my very best, I promise you guys. All right? So let's think about this translation of this point, which was 1212, and it's been translated or slid to 2420. All right? There's a great notation for that notation right there, for that translation. And it looks like this. It's really simple. We're going to take every point x, y, every one of these anchor points, and to every x, we're going to do what? Well, how far is it from 12 to 24? We're going to add 12. And every y, well, how far is it from 12 to 20? We're going to add 8 to all those y's. All right? Now, I'm going to go out of order for a second because I want you to see this. Let's take the front right foot and picture that translation. 12 units to the right and 8 units up. And I drew kind of like a slope triangle. I put it above so you can see a little clearer. But anyway, look at this horizontal distance right there. That is exactly 12 units. And the vertical distance is exactly 8 units. So this front right foot, after the translation, will end up right here. just like the tip of the nose ended up right there at 2420. Okay, now let's do it with the other anchor points in order. So now we're going to go to the the front, the left. How did they say this here? Center of left front foot. So center of left front foot right there. All right. Well, what are we going to do? We're going to add 12 to our x. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, and then we're going to go up 8. 1, 2, 3, 4, 5, 6, 7, and 8. I hope I counted those right. You'll forgive me if I did not. Oh, look at that. We have a winner. So this left front foot will slide to that point right there. So now we have 3 of our anchor points transformed already. Now, let's go to the belly. Same thing. Let's go 12 units to the right. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And then 8 units up. Oh, I wish I could see that better. 1, 2, 3, 4, 5, 6, 7, and 8. Wow, those are all lined up. I don't know. There it is right there. Cool. All right. Now, where are we at? Are we at the left rear foot? Let's see. Center of left rear foot right there. All right, same thing. Let's do it again. 12 to the right. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And 8 up. 1, 2, 3, 4, 5, 6, 7, 8. Whew, I was worried because I couldn't see all those hash marks. And so this left rear foot is going to end up right there after the translation. Now where are we at? Point of the tail. Point of the tail right here. 1, 2, 3, 4, 5, 6, 7, 8. This is going to be tough. 9, 10, 11, 12, and then 8 up. 1, 2, 3, 4, 5, 6, 7, and 8. Right there. Point of the tail. There's the translation. And then what do? The center of the rear right foot. That'd be this right here. So let's go. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, and 8 up. 1, 2, 3, 4, 5, 6, 7, 8. I hope I'm still got this down. Woohoo! Yeah, there we go. And there's the translation of the right rear foot. And then what do we go to? The back, which is right here. All right, let's count this carefully. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, and then 8 up. 1, 2, 3, 4, 5, 6, 7, 8. Right there. Winner, winner. There it is. And we already did the front right foot, so there's all of our anchor points, which means this lizard is now lounging on that rock, and that's why they call this one the lazy lizard. Okay, I thought I was going to say lounging lizard, to be honest with you. I like lazy lizard. That's fine. Okay, great. So that's a translation. Remember, a translation is nothing more than a slide. A slide on the plane without rotating or flipping. Okay, and so we're going to keep the same size and shape. And you guys, I know this drawing's a little rough, but I tried to draw it on the computer. Kind of tough, but I did my best. Okay, here's our next transformation in leaping lizards, and I am in a classroom right now and my students are testing, so I'll try not to be as loud as normal. You might have to turn up your volume a little at home to hear this well. Sorry about that. Maybe my video technician can handle this too. Anyway, let's see. Let me read this first part here and make sure we're on top of everything. Each statement below describes a transformation of the original lizard. Do the following for each of the statements. Plot the anchor points for the lizard in its new location. connect the preimage and image anchor points with line segments or circular arcs, whichever best illustrates the relationship between them. All right, and this one we're going to do lunging lizard. Okay, and so for lunging lizard, we're going to rotate the lizard 90 degrees about point A, which has coordinates 12, 7. So it looks like the lizard is diving into the puddle of mud. All right, right on. So let's take a look at that then. So here's our original lizard again, all right? And we're rotating. Let me make sure I have these directions here. We're going to rotate 90 degrees counterclockwise about the point 12, 7. So whenever you do a rotation, you need your point of rotation. In this case, that is 12, 7. Right there, look, they highlighted it for you already. And now you guys picture a 90-degree rotation counterclockwise. I hope you guys can picture 90 degrees. And if I'm rotating counterclockwise, I'm rotating to the left. So this angle right here would have to be 90 degrees. Now, it's awesome when we have like vertical and horizontal like this to form the 90-degree angle, because look at this. Let me see. This point is 1, 2, 3, 4, 5 points above, 5 units above the point of rotation, I should say. So that means if I rotate 90 degrees counterclockwise, it's going to rotate like that and end up 1, 2, 3, 4, 5 units to the left right there. Now, again, we are on a grid right now, so we're not going to use like a compass and do a circular arc. It's easier on the grid paper if you just picture if this point, 5 units above the point of rotation, is rotated 90 degrees counterclockwise, it's going to end up rotating over here and be 5 units to the left of the point of rotation. Okay, now let's do that for each of these. Now, you guys notice that I already did a 90-degree angle, and you guys could do that with a protractor and get a perfect 90-degree angle, but the question is the distances, and you could actually measure these distances and get this perfect, but I want to show you how to do this on the grid too, all right? Because it's all about slope, okay? And remember the rule. Slopes of perpendicular lines are negative reciprocals. We're going to really develop that this unit. Okay, so I'm going to picture the slope. I'm going to picture we're going from this point to the point of rotation right there. And I'm actually, usually I would go left to right, but I'm actually going to go right to left. So I'm going down 1, 2, 3, 4, and 5. That's a rise of -5. And then I'm running -1, -2, -3. Okay, now picture this. -5 over -3 is the same thing as 5/3, and if we had gone from the red point to that blue point, we would have risen 5 and ran 3. Okay, but now perpendicular slopes are negative reciprocals. So that means the negative means the opposite, and since this is positive, I'm going to start over here with a negative and then a reciprocal. Well, the reciprocal of 5 over 3 is 3 over 5. So this is going to be a -3, or excuse me, a +3 over -5. So look what I'm doing now here. I'm going up from this point. If I go up 3, 1, 2, 3, and then to the left, -5, -1, -2, -3, -4, -5, I'm perfect right there, and that's where that needed to be. Now let's keep doing that again. And where are we at? That was the left front foot. And now I go to the belly right there. And I'm going to do a 90-degree angle with legs that have the same distances. Just like this. All right? And again, I would probably crunch these numbers first, but picture the slope going from this point to my point of rotation. I'm dropping 1, 2, 3, 4, 5. That's a rise of -5. And I'm running -1, -2, -3, -4, -5. -5 over -5 is a positive 5 over 5. So I'm going to do the reciprocal of that with a, what is it? I'm going to go up 5, and then I'm going to go to the left 5. Notice now this is 5 over 5, and this is actually negative 5 over 5. Now watch. Rise 5. 1, 2, 3, 4, 5, and run negative 5. 1, 2, 3, 4, 5, and there's that point right there. All right, we're transforming these anchor points with a 90-degree rotation counterclockwise. All right, so what do we do after the belly? I bet you we're going to do the left rear foot. Yep, center of left rear foot. So again, I'm going to do a 90-degree angle from the left rear foot to the point of rotation, and then 90 degrees, and go the same distance. Now, I'm going to find this distance perfectly with slope again. So to get from this point to this point, I'm going to drop 1, 2, 3. So that's a rise of negative 3. And I'm going to run 1, 2, 3, 4, 5. Let me count that again. 1, 2, 3, 4, 5, 6, 7. Negative 7. Now that's a positive 3 over 7. And if I do the reciprocal, the 7 goes on top. And I need to make this negative, so I'm going to put a negative 3 in my divisor. Now watch. Let's go up 7. 1, 2, 3, 4, 5, 6, 7. And go to the left 3. 1, 2, 3. Hey, look at it. That was perfect. Right there we have it. Okay, we're getting there, you guys. So after the center of rear right foot, we do the back, and they're calling this the back right here. So let's get the slope. Okay. Oh, we're not doing the back. We're doing the point of the tail. Okay. I was at the wrong spot again. So the point of the tail. So let's do this. 1, negative 2, negative 3, negative 4, negative 5, negative 6, negative 7. And then I'm running negative 1, negative 2, negative 3, negative 4, negative 5, negative 7 also, which is a positive 7 over 7. What's the reciprocal of 7 over 7? 7 over 7. So I'm going to go 7, but then I have to be negative over here, so I better make this a negative 7. And now let's double check and make sure it worked. Rise 7, 1, 2, 3, 4, 5, 6, 7, and run negative 7. 1, 2, 3, 4, 5, 6, negative 7. Yeah, another one works. Okay, don't let me get lost now. We just did the point of the tail. So now we're at the center of the rear right foot. Okay, here I am right here. And let's draw our 90-degree angle. And let's make sure this distance is correct over here. So I am going negative 1, negative 2, negative 3, negative 4, negative 5, negative 6. And then I'm running negative 1, negative 2, negative 3, negative 4, negative 5, negative 6, negative 7, negative 8, which is a positive 6 over 8. And the reciprocal of 6 over 8 would be 8 over 6. But since this is positive, I'm going to have to make this 6 a negative, which means I'm going to go up 8. Let's check it now. 1, 2, 3, 4, 5, 6, 7, 8, and then to the left 6. 1, 2, 3, 4, 5, 6, and there I am right there. It worked again. Okay, only 2 more to go here. And let's see, where are we at? The back. The back. So let's draw our 90-degree angle. And let's check this distance right here. All right, so for that distance now, well, let's use our slope. So to get from this point to my point of rotation, I'm going to drop 1, 2, 3, 4, 5, 6, 7, dropping 8, and running 1, 2, negative 3, negative 4. That's a negative 5. And that's a positive 8 over 5, whose reciprocal is 5 over 8, but this has to be negative, so I'm going to make that a negative 8. All right, let's see how we did here. 1, 2, 3, 4, 5. Yeah, and then negative 8, negative 1, negative 3, negative 4, negative 5, negative 6, negative. Look at that, negative 8. Okay, great. Now we have the right front paw there. The front right foot. Oh, this is going to go a long ways negative. -1, -2, -3, -4, -5, -6, -7, -8, -9. Wow. -9. Oh, and I drew my right angle in there too. And then how far am I running? -1, -2. So that's a 9/2, and the reciprocal of 9/2 would be 2/9. But since this is positive, and negative over negative is positive, I better put a -9 down here. Now let's check it. Let's rise to 1, 2, and run -9, -1, -2, -3, -4, -5, -6, -7, -8, -9. And there's all my anchor points right there. So if I put those anchor points into the computer is going to take those anchor points for the tip of the nose, the center of the left foot, belly, center of the right foot, point of tail, center of rear right foot, the back, and the front right foot. Wow, that's a mouthful. And it's going to give me the perfect lizard. And that lizard is diving right into that pond right there. And we like to call this the lunging lizard. Okay, our last transformation will be a reflection over a given line. So we're going to take all of those anchor points and we're going to reflect them over a given line. So let's read the problem here. Leaping lizard. Reflect the lizard about the given line, y equals 1/2 x plus 16. So it looks like the lizard is doing a backflip over the cactus. How creative. Okay, so let's remember y equals 1/2 x plus 16. So here is our leaping lizard right here, and we need to reflect this leaping lizard over probably this line, which was y equals 1/2 x plus 16. So it looks like the lizard's doing a backflip over that cactus. Oh, how cool. All right, let's double check the line though, okay? Let's see, this line has a y-intercept of 16, right there, and a slope of 1/2, meaning I'm going to rise 1, and I'm going to run 2, right there. So that looks like my line perfect. Okay, so let's talk about slope now. You guys know that the slope of that line of reflection is 1/2. Now, the definition of a reflection. This is critical. All right, here it is right here. The line we are reflecting over, like this bold red line that I just did right there, must be the perpendicular bisector of the segment connecting our pre-image and image. So if we begin by the point at the tip of our leaping lizard's nose right there, and we reflect it over that line, I think you can picture that that point's going to end up out here somewhere, right? And you could do this very accurately with a ruler and a protractor, but they're trying to get you to use this grid to get it done. Okay? And to do that, you need to understand the concept of perpendicular slopes. So, here it is right here. Perpendicular lines have slopes that are negative, or what we call opposite reciprocals. So remember, this line had a slope of 1/2, and what is 1/2 perpendicular to? Well, negative or opposite means, well, if this slope is positive, then the slope of a perpendicular would have to be negative. And then we have our fraction. Here's my fraction bar right there. And what is the reciprocal of 1/2? That would be a 2/1. So a line with a slope of 1/2 is perpendicular to any line with a slope of negative 2/1. Very cool. All right, so let's get to work here. Wow, we have a lot of anchor points that we need to reflect using slope here, okay? So watch this. Let's apply that slope, negative 2/1. Now typically, you guys, when you do a negative 2/1, don't you drop 2 and then run to the right 1? But that's not going to get me over that line right there. So I'm going to think of my negative 2/1 as, how about 2 over negative 1? Aren't these the same slope right here? So what I'm going to do is rise 2 and run to the left. for a negative 1. So let's do that. Let's go 1, 2, and then to the left 1, put a point right there. Now I know the image of this pre-image right here has to be on this ray right there somewhere. And I hope you see the 90 degrees, the perpendicular to this happening there. So let's do that slope several times. And right now let's do the slope enough times to get as close to this line of reflection as we can. So up 2 to the left 1, up 2 to the left 1, up 2 to the left 1. Look at that. They started off with an easy one. That's perfect. So how many times did we just apply that slope? Well, I know I'm going to the left 1 every time. So let's say we went to the left once, twice, 3 times, 4 times. So we just applied this slope 4 times to get to our line of reflection. That means our image, we just have to do that slope 4 more times. And let's skip a few steps here. If I apply this slope 4 times, won't I be rising 8 and running -4? Check it out. 1, 2, 3, 4, 5, 6, 7, 8. Now go to the left. -1, -2, -3, -4. I think we have a winner. And that red point is the image of our pre-image, the point at the tip of our leaping lizard's nose. Okay, now you know I'm struggling with the order of how I reflect these anchor points right here, but I believe the next one is the upper left hand right there. So what did I call that again? Yeah, that was perfect. Oh, let me talk about one more thing though. Let's see this definition right here. Remember, the line we are reflecting over must be the perpendicular bisector of the segment connecting our pre-image and image. Okay, so bisector means that this red line of reflection bisects this segment from the tip of the nose to the image on the other side. And you know how we show that in geometry? We just put a hash mark here and a hash mark there. That tells us that these 2 segments are congruent, the same length. And then perpendicular means this must be a 90-degree angle. And there's your symbol for a 90-degree or right angle right there. Okay, now let's go ahead and apply the slope for, and what did we call this anchor point right here? The center of left front foot. All right, so let's do the same slope. We're going to go up 2 and over to the left 1. I hope this works perfect. So there's my first point. So let's just draw the ray through those 2 points. And I did a dash line, but you don't have to. You can do a solid line right there. And notice how our rays are parallel because they have the same slope, 2 over -1. Now let's apply that slope and get as close to our line of reflection as we can. Up 2 to the left 1, up 2 to the left 1, up 2 to the left 1. Oh, drag, this one won't be perfect. Up 2 to the left 1, how about right there? Okay, so you know what? This one isn't going to be quite as easy, and yes, we are going to have to do a little bit of estimation, but we can handle this. So how many times did we apply that slope this time to get from here to right there? Let's see, that looks like 1, 2, 3, 4. Looks like we did it 5 times. So let's apply that slope again 5 times, or applying 2 over -1 5 times, that would be 10 over -5. So let's just go up 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Woo! 1, 2, 3, 4, 5, and there we are right there. You guys notice too, I had to expand this grid. I know it's not perfect, but your MVP curriculum didn't give you a grid big enough to do this reflection. I know we're right on the borderline now, but we have more points to reflect. So I helped you out there a little bit. Now, by the way, this is not the image. Remember, we were a little bit over right there, and horizontally that's about a half a unit. So that means I'm going to have to go horizontally from this point about 1 unit to the right. So I'd say my point of reflection will be about right there. And there we go. This image, or this point, is the image of our pre-image, the center of the left front foot. Okay, and almost perfect, I'd say. Okay, what comes next? Oh, the belly right here. So let's apply our slopes again. 2 over 1, 2 over 1, 2 over 1, 2 over 1. Uh-oh, 2 over 1. Oh, we did that one perfect again. Oh, here, I did my first slope and I drew my ray. And then if I did that slope several times, I ended up right on the line again. Now, how many times did we do the slope that time? Because we'll just do that again and we will have our image. Well, let me see. 1, 2, 3, 4. Looks like 5 times again. So can I go up 10 and to the left 5? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. To the left 1, 2, 3, 4, 5. Ah, there I am right there. Oh, and notice red dot because I know that's the image right there. I don't have to estimate here. Okay, that one's almost perfect, I'm sure. Okay, well, where are we at? Oh, we are at the center of the left rear foot, this right here. So let's apply our slope. Rise 2, run to the left 1. Okay, and I'm going to draw my ray through these 2 points now. There we have it right there. And let's keep doing our slope to get as close to our line of reflection as we can. Maybe this one's going to be perfect again too. That would be cool. Up 2 and over 1. Up 2 over 1. Up 2 over 1, looking good so far. Up 2 over 1, looking good. Oh, we're just about, but not quite there. All right, well, that's okay. So when we get do that slope again to get to the other side several times, we're going to have to bump our approximation up the ray a little farther because this one came up slightly short. All right, so how many times did we do that slope? Well, let's see. Count this carefully. 1, 2, 3, not there yet. 4, 5, not there yet. I think that's 6. Is that 6? Oh, I lost my arrow. I better count them one more time. 1, 2, 3, 4, 5, 6 is right there. Yep, so we've got to apply that slope 6 more times. And if I apply the slope 2 over negative 1 6 times, aren't I going 12 over negative 6? So let's try to do this in one shot. 1, 2, 3, 4, 5, darn it, 6. Sorry, my mouse pad isn't this big. 7, 8, 9, 10, 11, 12. Did I say 12? And then 1, 2, 3, 4, 5, 6. There I am. Yep. Okay. Now remember, we were about 1/4 of a unit short horizontally, so that means I've got to go about 1/2 of a unit short horizontally up here. So I got to go 1/2. And so I probably put that point. I bet you I put it about right there. Oh, look at us. Okay, a little short of that. Not bad, though. Okay, good. Remember, that's just an approximation. We're doing our best, you guys. Okay, now, where are we at? That was the center of the rear right foot. So now we got the back. And the back is where? Right here. So let's apply our slope again. 2 over negative 1. Right there. Uh-oh. Did I skip one? Let me go back. All right. After the left rear foot. Oh yeah, right there. I was right there. I need to do the point of the tail, you guys. I'm sorry. So I'm going to start at the point of the tail and apply that slope up 2 to the left 1. Right there. That's better. All right, now let's draw this ray. There it is. Now let's keep applying our slopes and get as close to that red line of reflection as we can. So we are going to go up 2 and to the left 1, up 2 to the left 1, up 2 to the left 1. Ooh, this one's going to be off, up 2 to the left 1, and I ended up right there. Oh, I did the short one, okay, which I guess that's about even, so it doesn't matter. Right there. Okay, so how many times do we apply this slope? Let's see. 1, 2, 3, 4 times. So let's do that slope again 4 times, which would be 8 over -4. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4. Right there, I believe. Sorry, I got to get a bigger mouse pad though. Okay, now remember, you guys, we came up horizontally a little over a half a unit short, it looks like. So I got to go a little over 1 unit to the right here to get this. So this is going to be right in here somewhere. Okay, not bad, not bad. Good approximation. Okay, so where are we at? That was the point of the tail. And after the point of the tail, we're going to go the center of the rear right foot. Whew. All right, this one's going to be a lot of slopes. Right here, center of the rear right foot. So we're going to go up 2 and over 1. Let's put a point right there. And let's draw our ray. Booyah! All right, good. Now, let's get our slopes as close to that red line of reflection as we can. So up 2 over 1, up 2 over 1, up 2 over 1. How close is this one going to be? Up 2 over 1. Not bad. Yeah, right there. Just slightly short this time. All right, you know what I got to do? How many times did we just apply that slope? All right, so let's see. Notice how I use the horizontal. 1, 2, 3, 4. Oh, 5. One more. So we applied that slope 5 times. So let's do it again 5 times. 2 over 1, up 2 over 1, up 2. Come on, mouse. Over 1. I think I'm there. Up 2 over 1. Oh my gosh, I lost count when I lost my mouse. I've got to do that again because I'm not blowing it now. Up 2 over 1. There's 1. There's 2. There's 3. All right, there's 4. And is 5 right there? Oh, cross your fingers. Woohoo! We did it. Right on. Okay, but remember, I was slightly short here, so I got to double that horizontal distance. So I don't know, about right in here. Probably put that about right there. Ha ha! Look at that one. Oh, that one was nice. Okay. Wow, are we running out of points? Oh, looks like we still have to do what? The back. Here's the back. Okay, wow. All right, well, let's do our initial slope. Let's go up 2 and over 1, put a point right there, draw our ray. Now let's keep going, up 2 over 1, up 2 over 1. Oh, is this one going to be? No, it's close, so up 2 over 1. Right there, okay. Now, how many times did we do that one? And we were from the back, correct? So let's see, from the back we went 1, 2, 3, looks like 4. So we got to apply that slope 4 times. So we're going to go 8 to -4, rise 8 and run to the left 4. 1, 2, that is the right one, right? I think so, yeah. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4. Right there. Okay. Wow. Okay. Now look at that one too. Now this one was slightly beyond the line. So that means I'm going to be slightly below here. Probably put that point, I don't know, about right there, didn't I? Haha, look at that. Nice. All right. I believe we only have one more point to reflect, and that's the point on the front right foot. All right, let's do our initial slope, up 2 over 1. Draw your ray. Booyah! There we go. This one's going to be easy, isn't it? Nice finish. Up 2 over 1 and up 2 over 1. Oh, I'm not perfect. I thought maybe the last one they'd have us all perfect. But how many times did we do that one? Let's see. 1, 2, 3 times, right? So let's do it again. Up 2 over 1. There's once. There's twice. And there's 3 times right there. Now, let's get our image. This was slightly long there. So that means our image is going to be about right in here somewhere. Yep, right there. And we have now reflected all of our original points on our leaping lizard over the line y equals 1/2 x plus 16 to get these images over here. And now we tell the computer, hey, would you please draw my lizard based upon those images of our original anchor points? And the computer is going to go, well, Gibbons attempted to do a tracing, and it's rough, but we'll do our best. There it is right there. And do you guys agree that it looks like our lizard is leaping over the cactus? Picture that backflip, just like somebody who does the high jump. I can picture my lizard now. That's pretty cool. All right, in closing, we really hit the transformations hard for the first section in a module, okay? And I had to add a little bit extra there because of time with quarantine and such, we only have the opportunity to do the first 4 sections of module 6. So I did put a little extra in there for you guys today. All right, but I hope you guys now have the concept of a translation, a reflection, and a rotation. You guys have a great day and get that ready, set, go done. Leaping lizard, beautiful.